I'm Anthony Sargant. I'm a metrologist here at Fluke, and today we'll be realizing a triple point of water. What we have is a triple point of water cell. It has been supercooled to about -5°C overnight. And the water is so pure, it can actually go below zero without freezing. This method of a triple point realization is called a slush point. And the water won't freeze until it's agitated and the nucleation will start. So all I'm gonna do is rock it back and forth, and you're gonna see it transform really fast. This is what we call a slush point. So right now you have the water vapor, ice, and water existing in all three phases. And this is an intrinsic standard, and it is exactly 0.01 degrees C. Now this is a method that can be used, but it's not used that commonly here because it doesn't last very long. So I'm gonna take this over back to the bath, and then I'll show you another method. In this method, the cell has been cooled for several hours at 0 degrees C. And we're going to use dry ice to form a mantle of ice inside of the cell. To do that, we'll put a little bit of ethanol. We'll basically just scoop some dry ice into the cell, and you should see it start to boil. You'll start to see an ice block forming around the center column. Now we want to keep doing this until a nice ice mantle has formed all the way to the top. Once we have a good amount of ice forming towards the bottom here and a little bit on the column, we'll put in what's called a quick stick, and that'll help to form the mantle. What will happen is we'll put dry ice and ethanol in here. You kind of don't have to pour any more dry ice at that point. You just kind of have to watch it. So you can see there's already some ice crystals that are forming around the column. Hard to see. Put a little bit more ethanol. You want a nice steady boil. So at this point, I'm going to go ahead and put the quick stick in. You want it just above the bottom so as not to put pressure. We'll go ahead and fill this column with ethanol. Right just below the top. We want to make sure everything is nice and even so we don't have too much ice forming on any one side. And this looks okay. That's nice and slushy. We'll keep adding. We'll put a lid on it, and then we'll just monitor it. So what we're looking for is ice formation around this center column. It's not going to be even. It's usually going to have a bulb around the bottom, but you want it to be a nice and even as much as you can. Another thing you want to keep an eye out for is If there's too large of a bulb on the bottom, you're going to introduce pressure on the glass. So if that happens, I like to just keep my hands around it and warm it up a bit. It helps to melt that ice. Another thing that can happen is what's called an ice bridge. It'll form around the top here. It is basically a layer of ice that will form on the top layer of water, and that will cause too much pressure inside the cell. So what we want to do if we see that is just, again, I like to just hold my hands over, and the heat from my hands will help melt that ice, keeping the pressure off the cell. You can also use a heat sink. This one will take a couple of hours, but when it's finished, it will look something like this. You can see you have a nice block of ice in here. You have water, and you have your water vapor at the top. So this is a usable triple point cell. This cell is probably about a month in age as far as the mantle, and we have been able to maintain this state for over 3 months with really good repeatability. I'll continue to monitor this cell until it's fully realized, and that's how you realize it's your point of water cell.